The properties of aldehydes and ketones are dominated by the polarity of the carbonyl group, which makes these molecules moderately polar. So because of this polarity, aldehydes and ketones are going to boil at a higher temperature than alkanes, which are nonpolar, of similar molecular weights. And because in the aldehyde and the ketone, that oxygen is not bonded directly to a hydrogen, they cannot hydrogen bond with each other. So aldehydes and ketones have lower boiling points than alcohols. So if we look at this series of 4 compounds of similar molar mass, butane, which is an alkane, propanol, and acetone, which is an aldehyde and ketone respectively, and then alcohol, we see the boiling points match our expectations for the strength of intermolecular force. So butane has the lowest boiling point at 0 degrees Celsius because it's a nonpolar alkane. Propanol and acetone both have similar boiling points around 50, so higher than that of the nonpolar alkane, but not nearly as high as the boiling point of propanol, which can hydrogen bond, and the boiling point of propanol is 97 degrees Celsius. So aldehydes and ketones are soluble in common organic or nonpolar solvents, and those with fewer than 5 or 6 carbon atoms are also soluble in water because that polar oxygen on that carbonyl group is able to accept hydrogen bonding from water. And simple ketones such as acetone are excellent solvents because they dissolve both polar and nonpolar compounds. So they have that nonpolar part as well as the polar, so they're highly versatile. So here's a graphic of hydrogen bonding of water with an aldehyde and a ketone. So water is going to be the molecule with the oxygen and the 2 white or gray spheres attached to it. And then on the left here we have an aldehyde where that carbonyl carbon is at the end of the chain. And so this carbonyl carbon has a partial negative, and it can interact with that partial positive of the hydrogen on that water molecule. And likewise in a ketone, here we have this carbonyl group. This oxygen on the ketone has a partial negative, and it can interact with the hydrogen, which has a partial positive on the water. So aldehydes and ketones cannot hydrogen bond with each other, but they can hydrogen bond with water because that oxygen in the carbonyl group has a partial negative charge. So to sum up, aldehyde and ketone molecules are polar due to the presence of that polar carbonyl group, and they can't hydrogen bond with one another, so they have lower boiling points than alcohols, but higher boiling points than alkanes. And common aldehydes and ketones are typically liquids. What else do we got here? And simple aldehydes and ketones, so those less than 5 to 6 carbons, are typically water soluble because they can hydrogen bond. The carbonyl oxygen can hydrogen bond with the water. And ketones are good solvents for many polar and nonpolar solutes. So for example, acetone is a good nail polish remover. So that nail polish is pretty nonpolar. And many aldehydes and ketones have distinctive odors. So if you ever smelled nail polish remover, it has a very distinctive smell. And ketones are less toxic than aldehydes.